Hi, check out what I saved from the dumpster. A classic Hewlett-Packard, none of this Agilent, let alone Keysight rubbish, 1740A 100 MHz dual channel analog scope. Oh, beauty, or CRO as we call it here in Australia, cathode ray oscilloscope. And that's what I still call it here in Australia, you know, pass the CRO, mate. And thanks to Charles at Trio Test and Measurement, who actually was... I'm quite surprised he was going to dump it, but anyway, he says that he was going to keep it, but then it failed, and they're moving shop, and they really had to get rid of some stuff. So he reluctantly decided to dump it, but asked if I would save it from the dumpster. So I was more than happy to. And look at this. It's a Bobby Dazzler. It works, but Charles said there was some weird stuff happening on the display. He left it on overnight, apparently, and like it was working fine. Then he left it on overnight accidentally, and yeah, came in the next day, and he thought he smelt something funny, so maybe some magic smoke escaped or something. But anyway, it seems just fine and dandy. Check it out. It's a Bobby Dazzler, and it's in excellent nick for the 1970s as well. The manual is printed in 1976, which we have for it. I'll show you. And but it's still got a very sharp trace. There's no screen burn-in. Everything seems to be working just fine on it. We trigger off channel B, and we can actually get channel B hooked up here. Let's have a look. I'm sure we can. Display B, trigger off B, bingo. There we go. Bob's your uncle. Look at that. So both A and B channels are working fine, the horizontal's working fine, the trigger all seems to be working, and it's got delayed sweep time base as well. So all the triggering seems to be just fine as well. We can whack it in normal mode, and there we go. It vanishes once we get outside the trigger window, or in normal it'll just roll, of course, when we don't trigger. So everything looks like it's working just fine. We can turn on time. Let's try times 10 mag. It's working. There we go. And it's an absolute winner. Can't fault it at all. And of course, as usual with some of these things, there we go. If we get in with the vernier, you can see that it's all itchy and scratchy there. So yeah, we have to clean that up. In fact, that one's not working at all. Yeah, it's a physical. Yeah, it's just dodgy as. Looks like channel A is doing a similar thing. It's doing the business, but you tap on it and yep, it's all scratchy. So we get in there with some we can clean those up with some contact cleaner most likely, but the actual main vertical one doesn't seem to have any issues, and the horizontal doesn't seem to have any issues. We've got our horizontal vernier. That seems to work pretty well. So this is in, for its age, it's in amazing condition. Whoa, hang on. Something's started to go horribly wrong here. Whoa. Whoa, there was something. I wasn't getting any response. I was getting, you saw that horizontal, I'm sure you saw that. Horizontal line there on the display, and then my vertical position adjustment wasn't doing anything. That was really weird. And it's done it again. It's done it again. I was playing around with the delayed time base here, which is very nice, by the way. It's got the nice vernier control up here, separate trigger level. It's got auto as well, sweep after delay, and manual. Let's try and reboot it. No? Reboot it. What? Oh! Repower it. Hey, there we go. We're in like Flynn. No, see? It's vanishing. Alright, hopefully I can show you this. I'll turn the intensity down. You can see the highlight there. Okay, so it's got intensity. And this is, what are we in? We're in auto trigger, delay trigger mode. And you can see our vernier. I can move that along. So we can actually, say, zoom into that edge there, and then we can use our delayed time base. Bingo, we've actually zoomed in to our time base there. And then we can do the auto mode, where it actually jumps between the trigger points. Very, very nice. I like that. That's a winner. Winner, winner, chicken dinner. And this would have been a very advanced scope. Well, there we go. It's just failed. Look, the vertical's gone. The vertical's gone, but you can see our horizontals, it's jittering. There's something happening with the, like, jittering on the horizontal. Okay. Whoop. Oh, hey, it's back. Oh, yeah, this is one sick puppy, I think. Anyway, this is very nice how you can get the intensified delayed sweep mode. You can either get that automatically or mixed mode operation, and it's just, yeah, it's terrific. This would have been really advanced back in the day. But check out what we got with it. The original operating and service manual. This thing is pornographic. This is how you do manuals. This one's printed in August 1976, so I don't know the original release date of this scope. I haven't done any research on it, but we've got into principles of operation, and you wait and see what we've got in here. Here we go. So this is the operational part of it. We've got our specs and all that sort of jazz, but then we start getting into the centerfolds. Look at the centerfold. Look at this. It's not even the centerfold. We're not to the center yet. But look at that. All the operational controls. Fan-freaking-tastic. Wow, do you get that sort of stuff these days? Not in fold-out form. Geez, you're lucky if you get a bloody PDF that has hardly got anything. Anyway, not much on actually how to use the thing because, well, everyone knows how to use a scope, but principles of operation, look, straight into it. So basically the rest of this thing is all principles of operation, service, schematics, everything, bill of materials, the whole works. So here is the theory of operation. Got ourselves a nice block diagram of how it all works. And check it out. This is how the complete theory of the main sweep and the integrator and how it all works. Wow, look at this. Fantastic bedtime reading. Then we've got performance tests and adjustments. If you want to do all that, it's just beautiful performance test records. And then here's the replaceable parts. Here's inside. We'll take a squiz inside, no doubt. There we go. And so they're all fold outs. And then replaceable parts. We've got exploded 3D diagrams. Oh, God, look at all that. My hat's off to whoever was at the drafts people at HP at the time who did this. They would have had a whole drafting department, back in the day to do all that. Look at the bill of materials. Wow, that's just insane. Manual changes. It's got the original, addendums. There you go, various changes. Here we go. But look at this. Component overlays. What else have we got? Look at this. How to take it all apart. And then, of course, we get into, ta-da, the good stuff. There's the schematic. There's where I suspect might be an issue. I'd be, golden rule of troubleshooting. Thou shalt test voltages. But, so there we go. So we've just got basic linear stuff happening here. Nothing fancy at all. But there's our CRT driver. There it is. There's our driver board with all the high voltage generation and everything else. Once again, we've got all the waveforms, all the test waveforms, no problems whatsoever. What else have we got? We've got gate assembly. What's this? Here we go. Is this channel A? Here we go. Here's the input. Here is the input schematic for those scope front end fanboys. There we go. It's all, JFET inputs, very typical for a 100 megahertz bandwidth scope like we've got in here. There's all the input attenuation, and that's interesting. They've got is that like a custom chip to do as the differential preamp? Look at that differential driver output. Basically, single-ended input there. Their ground reference there, but differential output drivers. And yeah, have they rolled their own custom chip there? That's interesting. I thought this would have been almost entirely discrete. So that's rather fascinating. But as you can see, there's just a ton of stuff. There's a lot of things that go inside well, this is a reasonably advanced dual channel dual channel 100 megahertz scope. You know, it's got the delayed time base in the auto and sweep and intensified modes and all that sort of stuff. So, you know, it's pretty much as advanced as an analog scope got back in its day. So as you can see, there's no shortage of stuff. That means there's no shortage of stuff to go wrong as well. So yeah, hopefully we can do something with this puppy. But yeah, there's the delayed sweep assembly. Oh man, beautiful. You could just, beautiful bedtime reading. I love it. I love it. Look at it all. Oh yeah, baby. And there's all the interconnection diagram for all the boards as well. Look at that. Fantastic. What a Bobby Dazzler. Whoa, there it is. It's been on for like an hour, and it's doing this funny business. So we can see the bottom of the square. I just had like the compensation square wave on there, and no, it's doing real funny business. So I'm not sure what the deal is there at all. Display, looks like doesn't matter whether we've got A and B. Doesn't seem to matter. It's still doing funny business. So yeah, that's one sick puppy. Let's power it off. And whoop. Oh, you can still actually, oh no, I thought you can still see the trace there. No, that's a reflection of the light. Sorry. There we go. It's come good. Let's put it back over here. And we're A. Nope. No good whatsoever. So, yeah. Oh, yeah, the position display doesn't even work anymore. Wow. There you go. So, that is one sick puppy. Beam find. Finds the beam, no problems whatsoever. But, horizontal works. There we go, horizontal position. But it does not like that vertical at all. There's nothing. Not a sausage. No vertical thing. So it looks like something possibly wrong with the vertical. Well, no, because you just saw it. The horizontal was playing up too. Interesting. Power supply perhaps? And here it goes again. Look at that. So that's sort of, it's almost like a classic old power supply hiccup or something like that, causing something to go, hey, look at that. That's hilarious. Wow. I like that. Check it out. That's bizarre. Look at that. Hope that's showing up on camera. Yeah, I think it is. Wow. And if I disconnect this, it's still actually measuring something. Something's getting through the... Oh, no, hang on. No, I just disconnected the 1 kilohertz signal on channel A there. Let's go to channel B. There we go. Wow. Jeez. Look at that. That's funny. Something's going on. I haven't got chop mode on, by the way. So it's nothing to do with the chop. Because if you don't know, old-fashioned analog scopes, they have chop mode and alternate mode where they let the display go across once and draw channel 1 and then draw channel 2 is alt mode. You put it in chop mode and then it actually has a high-frequency chopper that chops between the two inputs at once at slow sweep speeds. It does that. So that almost looks like it had something to do with that for a second, but wow, I've never seen anything like that. It's bizarre. And if we turn the puppy off and turn it back on again, we might find that it hasn't come good. It's got some other failure mode. No, not a sausage. So something serious. Hey, going backwards. Yay. Was that, I swore that went backwards, did it? Or was I imagining things? I swear I'm not running this video backwards. Oh, wow. Please do that again. Please. Come on. That's hilarious. There we go. We go. Hey, look at that swept back. So that's the, I was going to say it's like the retrace, the CRT retrace, but it, it should be quick, not slow across like that. It should be blanked, of course, not visible. That's bizarre. And there's some more funny business after a while. I push the beam fine, look at that. I think you'd probably be a bit foolish to initially start trying to analyze this and trying to pick a particular fault with it. You just go straight in, check the power supplies off the bat, because we're getting, vertical issues, horizontal issues, probably not the high voltage stuff, because we're getting CRT operations. So that's, and really it's not like the HV has actually collapsed down. So it's still doing the business there. But, so yeah, maybe main power supply, that's an obvious first bet. Anyway, let's crack her open. Take a look for some visuals first. Oh, by the way, something that wasn't very common back in the day, it's got usual AC, ground and DC coupling, but it's got 50 ohm input impedance mode as well. And you couldn't actually, if you just flick it like that, you couldn't accidentally go into 50 ohms. And that is a safety feature so that you don't, load down your line. You've got to actually pull it out like that and then put it down like that. And you can move it back, but you can't move it down. So that's very clever engineering. Someone was thinking. But if you ask me to nitpick about the design of this, look at just how small the font is. It's hard to get a relative size here, but if you didn't have good eyesight, is that 5 or is it 0.5? Decimal point is absolutely tiny. I can barely even see that on the LCD of my monitor, my camcorder here. So, it really is quite small, but anyway. Just a quick look at the back. Yes, we do have the very handy Z-axis input. If you don't know Z-axis, think of it as intensity modulation. So, X and Y on the screen, and then Z allows you to change the intensity of the displayed signal. That's very handy for external stuff, and how you can do those, U-scope demos and all those other real fancy graphical demos and stuff like that using the Z-axis input. And it's also known as the blanking input as well, because if you put digital into there instead of analog intensity modulation, you could essentially blank the trace out, so we can draw fancy stuff on the screen and then not have all those those trace and retrace lines actually show up. And we've got both main and delayed gated outputs, fantastic, and a couple of adjustments for the astigmatism on the screen and the trace alignment. Warning, Will Robertson 3000 volts beneath this, and tested by, good on ya, Rob, is it? Good on you, Rob. All right, let's lift her up. Just 4 screws on the top here, no wuckers, don't have to do anything with the tilting bail, which is really nice. And ta-da, we're in like Flynn. Look at that. Oh, that's very neat and tidy. Wow, look at look at these daughter boards. Beautiful. Nice 10-turn pots in there. That's very clean. Look at that. Wow, there's not a bit of dust inside this thing. It's really clean as a whistle. Wow. Anyway, you can see the, I of course love the buttons coming back here on their extender arms there. Look at that. There's not much, it's a bit flapping around in the breeze there. Not any bracing on that edge of the board, so you can maybe see the board move a little bit, but yeah, I love these old school scopes. And of course you've got the horizontal here going back, so you can probably should be able to see that there's our secondary time base. You can see that sort of like a multimeter wiped contact thing on the board down in there. So it's actually on dual sides. I can show you the other side actually. There we go. So you can see that down in there. So there'd be some internal wipers in there and contacts. You should be able to see the stopper come around there, and bingo, that's the end of the travel. That's for the delayed time base setting. It'd be really easy to spray some contact cleaner under there if you had to, but this one seems pretty good. And of course, that is for the delayed time base. If you do the center one, what happens? Well, there's our board for our, so this would be our delayed time base, our delayed sweep board. This would be our main horizontal time base board, or horizontal time base selection. The main horizontal oscillator could be down on the main board there, but yeah, nice. Check out the heat sinks on some of the metal can packages there. Old school. And there's our CRT, shielded of course, and no touchy. Now, interestingly, if we have a look at our main block diagram here, and here's this like ASIC chip I was talking about before for the differential preamplifier front end and driver, they call it a preamplifier substrate. So that to me implies some sort of maybe ceramic hybrid module or something like that. And I love the switch maintenance here. Look, use the Freon degreaser. Contact surface should be lubricated with something from Lubriplate, FMO, produced by the Fisk Brothers Refining Company. Does anyone know if they're still in business? Now, tucked right on the side of the CRT here is this interesting looking board. I believe this is the vertical output driver. And look, they've got a HP ceramic device in there. Looks like a ceramic hybrid of some description, and you can actually see contacts down in there. Very interesting. And package pinouts for the win. And there's the schematic for that vertical output board, and that looks like our ceramic hybrid module down in there. There we go. There's our plate, so it goes directly onto the plates, as you can physically see over here. And there we go. You can see that it the output of the board, right smack on the back there, it actually goes through the metal shield there, wired right in there, and goes straight in to the vertical plates, the vertical deflection plates. There we go. And if you're wondering where our mains voltage selection was, well, here it is down in here. They've actually got a little switch, a recess switch right down in there, and we'll see that hopefully when we take this off. Ta-da! Oh, look at the access you get on this thing. That is a thing of beauty and a joy forever. Oh, look at the layout. Everything's accessible. All the controls are accessible. Oh, it's just, there's minimum of internal wiring. Oh, it's fantastic. But check out our old school caps around here. Well, this stands out like a dog's hind leg. Look at the Nippon Chemicon cap in there. That's got, like, for all the world, modern replacement written all over it, doesn't it? Just seems out of place. Anyhow, if we have a look at our main power supply, look how accessible all this board is. It's just absolutely fantastic. We've got a linear transformer, of course. 1, 2, 3, 4, 5 bridge rectifiers down in there. All our various filter caps. And look at the beautiful wiring on our regulation pass transistors out here for our regulated rails. Fantastic. Everything neatly cable tied, and the caps are cable tied down, and it's brilliant. And one thing on old products like this, be it scopes or anything else, always beware of sockets like this. They were very often single wipe contacts, i.e. only contacts on one side, and they can get crusty and pitted and all sorts of stuff, so you might want to reset, and thermal expansion can mean the chips can wear loose and stuff like that, so you want to go in there and give them a push down, and maybe even get out your IC extractor, take them out, just inspect the pins, make sure there's no corrosion or anything like that. But these ones look brand new. I mean, this thing could have rolled off the assembly line yesterday. Look at that National Semiconductor chip. Got some weird-ass, probably custom HP part number on it. Is that a date 82, perhaps? 9th week? Maybe? Not sure. Nope, we have a date code, folks. There we go. 79. The 45th week, 1979. So this dates this scope to at least early 1980. And there's a genuine factory bodge. Look at that. Very nicely done. There's tacked this diode between the two pins of the switch there. Someone went, oops. But fair dinkum, I don't think I've ever taken apart such an old scope that's in such good physical condition. There's not a tiny bit of dust on there. It helps when these things don't have fans, of course. There's none of that fan cooling rubbish. And the capacitors, geez, that brings back some memories. Look at that Mallory brand. Yeah, Sprague, no worries. I can't say I've heard of a Sangamo. And none of this mu for micro rubbish. That's genuine MFD. Thank you very much. 5300 microfarads with a big M, the capital M. And I've mentioned this many times, but I'll say it again. Back in the old day when they made these scopes, you know, the 70s, even well into the 80s, there was no such thing as a nanofarad. Nobody used nanofarads. It was either microfarads, MFD, right? And no actual micro mu symbol like you get these days. It was MFD, maybe because they had to actually type things, you know, and you couldn't get a mu symbol on a typewriter or whatever, you know. So yeah, they use MFD, capital M. So it was either microfarads or it was picofarads, or puff, as it's called in the trade. So, you know, you would get a 10,000 puff capacitor, or you get a 0.001 microfarad capacitor. You'd never see nanofarads. I don't know about you, but I just think that's just nicely engineered how they've got this plate, and they've got all the adjustments under there, and it's all nicely silk screened, and look, they've got the trouble to put the heat shrink over here to keep those tidy. Ooh, look, they've got a little toroid there flapping in the breeze. They had to take the edge off something there, so they installed that afterwards, but it's just all beautifully neat and tidy. And look at the spaces down here, keeping these wires a separated distance. Is that because of a capacitance thing? They wanted, you know, a similar crosstalk. Is that like a differential output? So they had to keep them a set distance? Oh, check out that gold-plated puppy down in there. Looks like it's on a ceramic base with a gold top. He looks special. HP branded. And these output transistors, look at them. They've actually got connectors going directly onto the bent pins of the transistor. That is, I don't know whether that's brilliant or whether or not that's, I like it though. Just imagine how easy it is to repair that. Geez, you don't even have to stoke up the soldering iron. Well, hello, do we have ourselves socketed voltage regulator chips here? There we go, 45th week 1975 RCA 1820. That'd be like a HP part number, no doubt. But look, are they? It looks for all the world like they're socketed. If you get in there, yeah, you can certainly lever those up. Look at that. Wow. Metal can socketed flush with the board. Fantastic. And here's another good example why it's not a bad idea to have a couple of multimeters lying around so that I can actually measure all the voltages simultaneously, because when you've got a fault like this, it's good to see what's happening on multiple rails. You don't want to go probing around in there and dicking around. And sometimes if you're working on high voltage stuff, it can not be safe, so you want to go hands off and set up the rig like this. And you just want to be able to set it up so that when you've got a long-term failure like this that takes some time to materialize, you just want to turn the scope on and just leave it there, and so then you can sit there and just monitor all the rails. So there you go. I think we've got 5 volts, we've got plus minus 15 volts, we've got 42 volts, I think, and this is 122 volts. So I haven't powered it on yet. Let's give it a whirl and see what we've got. Make sure I've got none of them plugged into the amps jack foolishly. No, so let's give it a go. Here we go. 4.9, we've got our 5, we've got our plus minus 15, we've got our 42, we've got our 121. Everything's hunky-dory. There we go. And we have our trace. The scope's upside down. All the electrons are going to fall out. Oh, so there we go. We've got our trace up now. All we're going to do is wait. Could take tens of minutes, could even take an hour before it does something silly. But yeah, you just want to monitor those voltages. I'll come back when it's doing something. See if there's any funny business. You always want to check your power supply voltages first. First step for everything. Because I don't really trust these dodgy old Sprague caps. Well, they were fantastic quality back in the day, but they've been in there since 1980, right? So they've been in there for like 35 years. So yeah, so when these things heat up, the internal ESR, they could go bleh, so it could be causing funny business. Anyway, the only way to check that is to monitor the voltages. I'll come back. Well, I swore I saw that drop down there. I was just actually tweeting a photo of it. And here we go. If you don't follow me on Twitter, you probably should. If I can bloody expand that photo out. There we go. Look, dropped down to 33 there, 96 there. Oh, 11. There we no, the plus one. Look, 3.9 volts. Ta-da! I captured it just like as I was taking the photo, but it's come good again. So I think there's something wrong. I'll wait until it goes funny business on the CRT here, but I think we might have got something. Well, it's been on for well over an hour now, and absolutely nothing. 3 of the meters have turned off, and not a sausage. So since that initial little drop, which I don't know, maybe lasted a couple of seconds while I coincidentally took that photo, it hasn't budged since. So have we got thermal issues caused by the fact that we've got the case off? Now this actually happens. Murphy will get you every time, right? That, because we've got the lids off, like the heat's able to escape. It's not able to heat up as much inside as it normally would, and it's also upside down. So if there was an issue with the power supply, then it'd normally be upside down. The heat doesn't really have much place to go. It's trapped inside the thing, and so it's annoying. It's maybe time to thermally provoke it. And there's probably no point getting the freezer spray, because if there is a thermal issue in here, that takes some time to do it. It's going to be caused by heating up, not cooling down. If it's good, it's working fine, cooling it down is not going to be a problem. It's not going to be, greatly doubt it's going to be a joint somewhere, or maybe a socket. It's not going to be, probably not going to be a dry joint, a soldered joint like you might get on BGA devices or something these days. So cooling it down is not really going to help. You're probably clutching at straws there in this particular case. I think you're better off maybe going it over with a hairdryer, perhaps, or your heat gun, and potentially trying to warm it up. But hey, just for kicks, let me spray some stuff. See, everything's hunky-dory. I don't know. Spray some random boards. Spray some random chips. It's just not going to happen. So I'll try the old heat gun. I've got it set to the lowest it can go, 100 degrees, and we might just start having a look around, shall we? I have no idea if we're going to get anything, but hey, it's probably worth trying at this point. So, although, what I suspect is, though, a lot of you might actually be screaming at me at this point is, Dave, it's probably not the linear power supplies. It could be something. If you were paying attention in the schematics a while back, I'll show you in a second what I'm talking about. It could be some sort of current limiting happening further on inside this thing, which is dragging down all the rails, because you saw before, like it was 3.9, these were dragged down to 12, and these are basically all of them were down. So that's more indicative of, some other weirdness happening, potentially dragging them all down. I don't know, but we're not getting any luck there. So it might not be a thermal issue. Of course, this is not extensive. I'm not going to rule it out at all. But we've got nothing doing there at the moment. And here's the schematics for the linear power supply. And you can see, we've got a standard bridge rectifiers there as our main filter caps down there. And then we've got some of these regulator chips. You saw those in the sockets there. And they've all got current limit, current sense in there. You can see there's our pass transistor mounted on the back. That's why it's got these socket symbols with a separate thing. Means it's mounted off the board. There's a current sense resistor. And these all have current sensing in them. And same over here, we've got this one here, all got current limiting on them. So maybe there's, something not inherent in the power supply somewhere else in this unit that's actually causing all of these rails to drop. So yeah, it seems to be a time-based thing. So whether or not it's thermal, it heats up, or whether or not it's electronic in some way, or a combination, don't know. But the thing is, though, to bring all of these rails down, and you saw like all 5 rails drop there, to bring them all 5 down when they're linear supplies, it can't see a mechanism where it could be an individual like line. Let's say the 5 volts, something was happening weird over on this board, some board over here that was powered from the 5 volt rail, then the current limit should just limit that rail. It shouldn't drag down all the others. It's not like they're all linked together. Here's these 3 regulator chips here, and they're all doing the same thing. We've got a series pass transistor mounted on the back. They've all got their individual current sensing resistors and stuff like that. So why would the other ones over here drop? The 42 and the 122 volt rails drop. It's almost as if like the mains input over here was dropping. So I wouldn't rule out a mechanism where maybe something in the power supply or somewhere else is dragging down one of the rails, and then it's causing, it's upsetting the one of the secondary sides here, which is then affecting the primary, but you've got low impedance from the main, so it should, it's just, why would they all drop? All of them. All at once, as evidenced by that photo, but I cannot bloody well reproduce it. It's extremely rare, but perhaps the instant I took that photo, the mains dropped or something. That would be, that'd be a ridiculous coincidence. The mains is rock stable around here. So, yeah, but bloody Murphy, get you every time. Well, sorry folks, this thing is just not failing. It's near the end of the day, and it's probably been going like 2 hours now or something, and it's just is not failing at all. So yeah, I could probably put the case back on. I don't want to leave it like overnight running and come back in the morning, because Charles said that he did actually smell something. So yeah, I don't really want to risk the fire brigade being called or the lab burning down or whatever. So man, it's a long shot, but hey, it's expensive. If that alarm goes off, yeah, I could cover the sensor, but so I'm unfortunately going to leave it. Call it quits there. I know people hate this, where I don't actually repair something like this, but it takes time, and yes, I could sit on the video for, until I get around to, actually solving this thing and fixing it, but then, I think it's good material in its own right. I've got it's been going like 35 minutes or something now, so anyway, I hope you enjoyed that sort of tear down and first debugging and a little play around with this classic HP scope. And isn't it just gorgeously built? I love it. Fantastic. Huge thumbs up. Anyway, if you liked it, please leave comments and jump on over to the forum and all that sort of stuff. Support me on Patreon, etc., etc. Follow me on Twitter, blah, blah, blah. Catch you next time.